In this video, we will be factoring trinomials in the standard form of a quadratic expression. We will also be solving equations in the same standard form. Standard quadratic form is ax squared plus bx plus c, where a, b, and c are coefficients. These are what drive everything that we're going to be doing. The variables pretty much just follow along for the ride. A, b, and c will be numbers that we will be using for everything that we are trying to accomplish here. There are three basic methods for factoring quadratic expressions, the trinomials that we'll be working on. The first is trial and error. This has been around for a very long time. This is what I learned years ago, and this is what I dreaded when I thought of teaching the factoring methods. It's long, tedious, and extremely prone to errors. While teaching, I came across the grouping AC method. Some books call it grouping method, some call it AC method, and some call it the AC grouping or the grouping AC method. One way or the other, this method is quite common these days. It's quick and it has no hidden steps. Very little opportunity for error. And then we come to a shortcut. This is a method that, similar to the grouping AC method, has some of the elements of the trial and error. I find that it's quicker and easier. You do have to trust yourself when you're doing it, though, but I think you're going to do just fine with it. Trial and error method. Consider 5x squared minus 3x minus 2. In the trial and error method, the first thing you need to do is identify the a and c. And let me say this before we move any further. I do not want you learning the trial and error method. It is old, it is antiquated, and it is not effective or efficient. It's kind of like driving a Geo when you could be driving a Mercedes. I'm going to show it to you so that if you ever see it, you know what it is and you understand it, but I also want you to see how ineffective it is. So we identify the a and the c. That's going to be the 5 and the 2. Then we find their factors. Well, since 5 and 2 are both prime, that's actually pretty easy. It's just 1 and 5 and 1 and 2. We need to reverse one of the list. It doesn't matter which list, but we need to reverse one of them because we're going to have to be working through every possible combination of multiplication. So one of them needs to be reversed. Typically I would reverse the c. It doesn't matter which one. Then we need to multiply and add or subtract to equal b. And notice I circled the minus sign in front of the 2, in front of the c. That is the sign that tells you whether or not you want to add or subtract your products. So we try our first combination, the red to red. That's 1 times 1 and 5 times 2. That gives us 1 and 10. 10 minus 1 is 9. That does not work. We're trying to equal b, which is 3. So then we try the red to the green. We get 1 times 2 and 5 times 1. Notice what the result of changing the order, reversing the order of the factors of 2. Now we get a totally different product. 2 and 5, 5 minus 2 does in fact equal 3. So that's the combination we want. We want the 1 and the 5 and the 2 and the 1. So we get a difference of their products of 3, which is what our b term is. Then we fill in parentheses. Remember when we reversed the c term, the c factors? Well, now we need to reverse them again when we put them into our parentheses. And we do this because when we FOIL this all back together, we want the 2 being multiplied by the 1 and the 1 being multiplied by the 5. And notice the a term, the a terms, they just go in order, 1x and 5x. Remember I said the variables just kind of follow along for the ride. That's all they do. We put in the sign of b to the c factor of the larger product. Notice how complicated that sounds. The c factor of the larger product. Between 2 and 5, the products right here, 5 is the larger one, so we want the c notice I have it circled there, the C factor of the larger product is 1. That's what gets the same sign as the B. It's getting a little nasty, I know. But that's the way the sign goes into place. The other factor will get the opposite if we were subtracting, which we were, or the same if we were adding. So since we were subtracting, this sign will need to be the opposite of that sign. So the opposite of negative will be positive. And we get the factorization x minus 1 times 5x plus 2. And if we FOIL that back out, we will in fact get the original 5x squared minus 3x minus 2. Now many people look at this and say, well, that's not too bad. I do that all the time. That's the way I learned it a long time ago. And I admit, when the A and the C are prime, it is actually rather easy. It's more difficult to explain it than it is to do it. But consider this. 15x squared plus 23x minus 14. Let's run through the same procedure with this. We find the A and the C and get their factors. Then we reverse one of the list, doesn't matter which one. Excuse me. Then we get all the possible combinations of the A factors multiplied by the C factors. And we want them to subtract to equal 23. Now the list is a little bit longer. Before we only had 2 possible combinations. Now we had 8. When looking at the list, we're looking for 23. And we find it right there. That means we're using the 3 and the 5 with the 2 and the 7. We fill those into parentheses, reversing the C terms, giving the B sign to the 7, and then giving the other sign opposite so that they'll subtract. Which sounds good, except this is incorrect. This is not going to get us to the factorization we want. And the reason is because in my multiplication over here, I made an error. 5 times 7 is not 29. In my head, I had already subtracted 35 minus 6, and I put the result of 29. Then I subtracted 6 again to get 23. I should have picked a totally different combination and come up with a totally different factorization. Remember, I said prone to error. I had considered removing this error from this slide when I realized I had made it, but then it occurred to me, this proves my point, so I left it in. Prone to error. And here's the long and tedious. 24x squared minus 13x minus 60. All the factors of A, all the factors of C. Reverse one of them. I reversed the A this time because it was a shorter list. Doesn't really matter though. One way or the other, we're going to have to multiply all the A's times all the C's and find a combination where they subtract to give us a 13 result. I need to make some more room. And boom! That is a lot of different combinations. 48 different possible combinations to be exact. And somewhere in there we need to find a difference of 13. Which if you look closely, you'll see over here. So we need to use the 8 and the 3 and the 4 and the 15. Now, some people say, oh, I never have to do that many. Well, that's because they just get lucky or they give up before they get there. If you're using the trial and error method, the only way to make sure, absolutely sure, that you get check every possible combination is to go in order the way I did here. I started with the A factors of 1 and 24, and I checked them against the 1 and 60, 2 and 30, 3 and 20, 4 and 15, so on and so forth. Then I went to the 2 and 12 and checked all those. Then I went to the 3 and 8 and checked all those. And that's the way to do it, over and over and over and over and over again. Some people look at it and they say, well, it's going to be somewhere in this area. And so they try one combination and it doesn't work. Then they try another combination and it doesn't work. Try another one and it doesn't work. Then they lose track of what they've tried and what they haven't tried. And pretty soon they're trying some again that they've already tried, or they're completely skipping the ones that they should try, and it's always going to turn out that those are the ones you need. Long and tedious. Once the set of factors that you need are found, then it actually is very simple. We put those into the parentheses, reversing the C factors again. Put in the sign of the B with the larger of the C factors, and then put the opposite in this case so that they subtract. We would have done the same factor if we wanted them, same sign if we wanted them to add. That's the trial and error. Like I said, I do not want you learning this method. I just want you to be aware of its existence. I much would rather prefer you do the AC method. I had to throw that in just because I put so much time and energy into this one slide. It took me forever, and I was really excited to finally be done with it.